Today we are going to observe the magnetostriction phenomena in the transformer when the flux density in the transformer is increased. We can increase the magnetic flux density in the transformer by reducing the supply frequency or by reducing the number of turns in the primary winding. Since the supply frequency is constant, that is 50 Hz, and we are going to decrease the number of turns. By reducing the number of turns, we can increase the flux density in the transformer. For the experiment, here in between phase and neutral we have a 230 volts 50 Hz supply, and this is our auto transformer. 230 volts by 0 to 270 volts. Input is fixed to 230 volts, and from the output we can adjust the auto transformer output to from 0 to 270 volts. And here we are using the 0 to 1 ampere moving iron or 0 to 5 ampere moving iron type ammeter, and we are going to use the 0 to 300 volts moving iron type voltmeter. And this is our two winding transformer, and here primary winding is having 100% turns, 86% turns, 50% turns, and secondary winding also in between these two terminals we have a 100% turns. In between from this to this 86% turns. If we take the tapping from these 2 points, then it will be 50% turns in the primary winding as well as secondary winding. First we are going to connect the circuit for 100% turns in the primary winding. Now we can see the procedure. First we have to connect the circuit as per the given circuit diagram. Apply the rated voltage, that is 230 volts across the primary winding, that is across 100% turns in the primary winding, by adjusting the auto transformer output voltage. And then we have to note down the ammeter reading and observe the noise intensity in the transformer. After that we have to reduce the auto transformer output voltage to 0 volts. Then again we have to connect the circuit diagram for 86% turns in the primary winding in the transformer. For that, after connecting the circuit for 86% turns, we have to apply the rated voltage across the 86% turns in the across the primary winding of the transformer. Then we have to note down the ammeter reading and we have to observe the noise intensity in the transformer. Next we have to connect, after that we have to reduce the auto transformer output to 0 volts, and then we have to reconnect the circuit for 50% turns. For 50% turns, we have to gradually increase the auto transformer output. Then we have to see the ammeter reading. If the ammeter reading is more than the rated current in the winding, that is here rated current will be 1 kVA by 230 volts, that is 4.3 amperes. If it reaches the 4.35 amperes in the ammeter, then we have to stop the increasing the auto transformer output. Then we have to note down the voltmeter ammeter readings, and then we have to observe the noise intensity in the transformer. Now we can see the components present in the circuit. This is our auto transformer. First we should keep this auto transformer output to 0 volts, that is minimum position. This is our ammeter, it is for 0 to 1 ampere, and this is for 0 to 300 volts moving iron type voltmeter. And we can see the transformer. Here primary side is from common to 100%. In between we have total number of turns is 100% turns. If we use the common terminal and 86.6% turns, then turns will be 86.6% turns. In between these two we will have 50% turns. And secondary also same. This is a single phase transformer rated with 1 kVA. Primary side is 230 volts if we take the 100%, and secondary side also 230 volts, and rated current will be calculated by using the formula capacity rating by voltage rating. Here capacity is 1 kVA and primary side rated voltage is 230 volts. 1 kVA by 230 will be 4.35 amperes. We have connected this circuit as per the given circuit diagram. Now we are going to switch on the supply, and after switch on the supply, by adjusting the auto transformer output, we have to set the 230 volts across the 100% turns in the primary winding. Now we have set the 230 volts across the 100% turns in the primary winding. Now we can see in between common and 100% turns we have set the 230 volts, and we have to note down the ammeter reading. Now ammeter reading is showing 0.18 amperes, 0.18 amperes, and we can observe the noise intensity in the transformer. Noise intensity in the transformer. I think now you can hear this noise intensity. After taking the readings and observing the noise intensity, we have to reduce the auto transformer output to 0 volts. Then switch off the supply. Then we have to connect this, we have to switch this primary winding 100% to 86.6% turns. Then we have to switch on the supply, and we have to apply the rated voltage, that is 230 volts, across the 86.6% turns in the primary winding. We have set the 230 volts across 86.6% turns in the primary winding. Then we have to note down the ammeter reading 0.52 amperes. It is given. And observe the noise intensity in the transformer. Now the noise intensity in the transformer is increased when compared with the 100% turns. Now we are going to reduce the auto transformer output to 0 volts, and we are going to switch this 86% turns to 50% turns in the primary winding. And then from the last two observations, that is with 100% turns and 86.6% turns, for 100% turns we got 0.18 amperes as the no load excitation current, and for 86.6% turns we got 0.52 amperes. Means if we reduce the number of turns, current in the primary excitation current is increased. So we have changed the ammeter from 0 to 1 ampere moving iron type ammeter to 0 to 5 ampere moving iron type ammeter, and we have set the 50%. We have switched the primary winding 86.6% turns to 50% turns. Now we are going to increase the auto transformer output gradually from 0 volts, and we are going to see the ammeter reading, and you can also observe the noise intensity in the transformer. Here if we observe the voltmeter reading at 160 volts or 170 volts, we are getting 2.3 volts, 3 amperes we are getting for 180 volts. and if we increase further, we are getting current is increased. We know our rated current through the winding is 4.35 amperes. Now we have applied the 4.35 amperes and we got this amperes, 4.35 amperes at reduced voltage, means less than the rated voltage, that is 196 voltage we got for 50% turns. And you can also observe the noise intensity in the transformer. It is drastically increased with the reduced number of 50% turns. Now we can note down this ammeter reading and voltmeter reading. Then we are going to reduce the auto transformer output to 0 volts, and then we can switch off the supply. Now we can see the write-up for observation of magnetostriction phenomena on a single phase transformer. You can go through this write-up. Here observation tabular form is given for this experiment.